Hello, everyone. Let's continue the Linux Fundamentals Part 2. So in Part 2, we have 8 tasks. Let's start with the introduction, Task 1. Welcome to the second part of the Rework Linux Fundamentals series. We'll be applying our knowledge for the first installment in the series. So I highly recommend you completing that room before proceeding further. Okay, we have done that. In Part 2, we'll be teaching the in-browser functionality and help you get started in what is a fundamental skill in being able to log into and control the terminals of remote machines. Not only this, but the room will also have you unlocking the potential of your first few commands by introducing you to using flags and arguments, advancing your knowledge of the file system to perform some more useful commands such as copying and moving files, and discovering how access to files and folders is managed and how we can determine our access. Running your first few scripts and executables. Okay, let's proceed. Okay, task 2. The in-browser functionality was used in Linux Fundamentals Part 1 to get you directly connected to your first ever Linux machine without any hassle. In fact, the in-browser functionality uses the exact same protocol that we're going to be using today. This protocol is called Secure Shell, or SSH for short, and is the common means of connecting to and interacting with the common command line of a remote Linux machine. We will be deploying 2 machines in this room, your Linux machine in the Tryhackme attack box. What is SSH and how does it work? So Secure Shell, or SSH, simply is a protocol between devices in an encrypted form. Using cryptography, any input we send in a human-readable format is encrypted for traveling over a network, where it is then unencrypted once it reaches the remote machine, such as in the diagram below. My computer is the internet, the server. So I type hello world, it be encrypted into this, and then it will be sent again to hello. Okay. You can learn about the various types of encryption on a Tryhackme room, but for now, we only need to understand that SSH allows us to remotely execute commands on another device remotely. Any data sent between the devices is encrypted when it is sent over a network, such as the internet. Deploying your Linux machine, press the green Start Machine button below. Then scroll to the top, improve VM and VPN infrastructure. We've migrated to our improved regional infrastructure. Your VPN server is now automatically assigned based on your selected VM region. For business, for more, select a VM region that's geographically closest to you. Okay, that's good. So then scroll to the top of the page to see the deployment information similar to the screenshot below. Okay, now let's check right here. Target IP address will be shown in 24 seconds. Okay. The IP address displayed is the address of your Linux machine that you will be logging into using SSH. Take note of this for now. Okay. Deploying the Tryhackme attack box. Looking at the top of the page, press the Start Attack Box button. All right, let's take a look. Attack Box button. Okay. All right. And then the Tryhackme attack box is an Ubuntu Linux machine that is hosted online in the cloud and can be interacted with via your browser. You will be using this to interact with the machine that you deploy in this task. So let's start wait, 14%. Using SSH to log in to your Linux machine, but it's still loading. Anyway, the syntax to use SSH is very simple. We only need to provide 2 things, the IP address of the remote machine. Okay, so this is our IP address. Let's try to copy this. And then the correct credentials to a valid account to log in with on the remote machine. So if the remote machine has a username, that would be Tryhackme. So for this room, we will be logging in as Tryhackme. Okay, so from the other server, which is our target machine. So our target machine pretends this is um our computer, and then we will be using another computer connecting. I mean, we will be connecting to another computer using SSH, and the other computer has a username Tryhackme, and also the password is Tryhackme. So we will be using that other computer's username and password so that we can connect to that one. Okay. So we are going to use password Tryhackme without the quotation. Okay. Quotation marks. Let's use the IP address of the machine displayed in the card at the top of the room as the IP address and its user. Okay. To construct a command to log in to the remote machine using SSH, the command to do so is SSH and then the username of the account. All right, so let's try that. At the IP address of the machine. But first, we need to open a terminal on the Tryhackme attack box. All right, so this is the terminal. Okay. So the command to do so is SSH, and then username. Okay, the username is Tryhackme, @ and then the IP address. Okay, press enter. Right, are you sure you want to continue? Yes. Password, Tryhackme. Okay, welcome to Ubuntu. So it seems like we are inside that computer now. Okay, so replacing the IP address with the IP address for your Linux target machine, once executed, we will then be asked to trust the host. Okay, that's what we did. Then provide a password. We did as well, which is also Tryhackme. Now that we are connected, but any commands that we execute will now execute on the remote machine, not our own. Very good. Note, when you type a password into an SSH login prompt, there is no visible feedbacks, just like what we did earlier. We don't see anything right here. We're just typing our password. You will not be able to see any text or symbols appear as you type the password. It's still working, however, so just type the password and press enter to log in. Okay, so I've logged into the Linux Fundamentals Part 2 machine using SSH. Task 3, Introduction to Flags and Switches. A majority of commands allow for arguments to be provided. These arguments are identified by a hyphen and a certain keyword known as flags or switches. We'll later discuss how we can identify what commands allow for arguments to be provided and understanding what these do exactly. When using a command, unless otherwise specified, it will perform its default behavior. For example, ls lists the contents of the working directory. However, hidden files are not shown. We can use flags and switches to extend the behavior of the commands. Let's try ls first. Okay. So using our ls example, ls informs us that there is only one folder named folder1. Okay. So let's just say we have important here, my file, my folder, and unknown1. Okay, as highlighted in the screenshot below. Note that the contents in the screenshots below are only examples. Okay, this is the example. So when we use ls, we didn't see that folder1 because this is just an example screenshot. But inside our computer that we use SSH, we have this 4. Okay, we have 3 files and a folder. Next, however, after using the -a argument, short for all, we now suddenly have an output with a few more files and folders, such as .hidden folder. Files and folders with dot are hidden files. Okay, so ls -a. Okay, so we have bash logout, bash h, bash rc, .cache, .profile, and then our normal folder. Okay. Now, commands that accept these will also have a help option. This option will list the possible options that the commands accepts, provide a brief description and example on how to use it. Okay, ls help. All right, so from here, we have everything from letter A. So we have a small a and capital A. Okay, all the way down to letter Z and 1. Okay, so here this is just a screenshot, so it's not complete. So you have to use the command to check all the complete um, arguments here, right? Because we will be using that to answer the questions later. This option is in fact a formatted output of what is called the man page, short for manual, which contains documentation for Linux commands and applications. So the manual page. The manual pages are a great source of information for both system commands and applications available on both a Linux machine, which is accessible on the machine itself and online. To access this documentation, we can use the man command and then provide the command we want to read, the documentation for it. So using our ls example, we use man ls to view the manual. Okay, let's try man ls. Oops. Okay, so here we have a lot. So ls means this directory contents. Okay, a all the way right here. So all of the information is here. All right. So explore the manual page of the ls command. Now we already explore everything. We can see starting from the top, what the name, the synopsis, descriptions here. The mandatory arguments to long options are mandatory for short options too. Okay. List information about the files, the current directory by default, sort entries alphabetically if none of CF, top socks, nor sort is specified. Okay. Okay. Exit the status, 012, author, reporting bugs, copyright, see also. Okay, next. What directional arrow key would we use to navigate down the manual page? Okay, so it says navigate down, navigate up, left or right. So navigate down. Okay, so that's down arrow. So if you want to navigate to up, or you can use up arrow or down arrow. Well, you can also use your, if your mouse has this kind of like wheels in between your click or your left and right clicks, yeah, you can also use that. That's what I actually use, not the down arrow. But here we are using arrow key. So it's a down arrow key. What flag would we use to display the output in a human readable way? So all you have to do is to go back to the help or man ls, and then we can find that human readable way. So if you want to find it right here, just read it from A all the way down. So if you go all the way down, you will see here human readable. It's letter -H. Next is task 4. All right. Before we go to task 4, let's quit first. There we go. So we covered some of the most fundamental commands when interacting with the file system on the Linux machine. For example, we covered how to list and find the contents of folders using ls, and find and navigating the file system using cd. In this task, we're going to learn some more commands for interacting with the file system to allow us to create files and folders, move files and folders, delete files and folders. So more specifically, the following commands. So touch, mkdir, cp, mv, rm, and file. So touch means touch, and the purpose of this command is to create a file. So good. So file is just like the page of a book. Next is make directory or mkdir. It's to create a folder. It's like creating the cover of a book. Next is copy or cp, is to copy a file or to copy a folder. So we can cp a file name or we can cp a folder name. mv is to move a file or folder. So here we can move a file or we can move a folder to another folder. That's what I think. Next, RM, remove, means you can remove a file or we can remove a folder, and file means to determine the type of a file that is being used. So similarly to using cat, we can provide full path. Okay, directory 1, directory 2, dash note for all of these commands. Creating files and folders. So here we're going to use the touch and mkdir to create files and folders. Creating files and folders on Linux is a simple process. First, we'll cover creating a file. So first, we're going to create a page of a book. The touch command takes exactly one argument, the name we want to give the file we create. For example, we can create the file note by using touch note. It's worth noting that touch simply creates a blank file. You would need to use commands like echo or text editors such as nano to add content to the blank file. Okay, so we are going to use that touch note. But wait, before we start that, let's ls first to check what we have. We have important, my file, my folder, and unknown one. So we are going to use touch and note. And then we can ls. Okay, so we have the note. Inside the note, it's a blank page. There's nothing. It's like, again, this file is like page of a book, but this page of a book is still blank. So it says if we need to use, if we want to add something inside that note or inside that file note, we can use commands like echo, which we have already learned. Echo, and then echo this word. Let's say, hey, to note. Okay, and then now we can cat that one, cat note. Okay, so we can see here, we have hey. Next, it says also here that we need to use commands like echo or text editors such as nano. So nano is a text editor that we can use like echo. So we can use nano, okay, and then let's say note. Okay, we're going to use that note again. So this, we are inside the nano now, and we can see that the note hey as well. Now, let's add something. Hey again. Okay. Next, we are going to press the Control X, and then we save modified buffer by Y, and then file name to create, still note, just press the enter. Now let's cat note again. Now we have hey and hey again. So that's how you create or write something inside or on that note file. Next, if you want, you can practice it as well. Now, this is a similar process for making a folder, which just involves using the mkdir command and again, providing the name that we want to assign to that directory. For example, creating the directory mkdir my directory. So mkdir my directory. Okay, ls, we have my directory. Okay, that's a folder because it's color blue. It means it's the cover of the book. Next, removing files and folders. RM is extraordinary out of the commands that we've covered so far. You can simply remove files by using RM. Okay, so let's try. Remove files. Files means, the page. So let's try to remove our note. RM note. Remember, there are messages inside the note, hey and hey again. Let's see if it's if the note file is removable even though there are messages. Okay, ls. Okay, so the note is already gone, which means that it can be erased even though there are messages inside or not. Now, however, you need to provide the dash capital R switch alongside the name of the directory you wish to remove. Okay, so now if we wanted to remove a cover of a book, we have to use the -r. So rm dash capital R and then my directory. Okay, ls. Okay, so my directory folder is gone. Next, copying and moving files and folders. Copying and moving files is an important functionality on a Linux machine, starting with cp. This command takes two arguments, the name of the existing file, the name we wish to assign to the new file when copying. cp copies the entire contents of the existing file into the new file. In the screenshot below, we are copying node to node 2. Okay, so let's try. Let's use touch to make another file. Okay, ls, we have the node. Okay, so we're going to copy. Let's say copy node to node 1. ls. So we have node and node 1. Okay, so if we, no, there's nothing inside the node. So what if we add something? Echo, hey, node. Okay, copy node, node 1. ls, cat, node 1. Okay, so it can be copied too. Next, what else? Moving a file takes two arguments, just like the cp command. However, rather than copying and or creating a new file, mv will merge or modify the second file that we provide as an argument. Not only that you can use mv to move a file to a new folder, but you can also use mv to rename a file or folder. For example, in the screenshot below, we are renaming the file node2 to be named node3. Node3 will now have the contents of node2. Okay, so not only that you can move mv, we can use mv to move a file to a new folder, but we can also use mv to rename a file or folder. Okay, let's try. mv node 1 to move node 1 to move node 1 to move to node 2. ls, oops. Okay, so now even as I use L, it's still good. Wow. Node 2. Okay, node 1 is gone. Determining file type. What is often misleading and often catches people out is making presumptions from files as to what their purpose or contents may be. Files usually have what's known as an extension to make this easier. For example, text files usually have an extension of .txt, but this is not necessary. So far, the files we have used in our examples haven't had extension. Without knowing the context of why the file is there, we don't really know its purpose. Enter the file command. This command takes one argument. For example, we'll use file to confirm whether or not the node file in our example is indeed a text file, like so, file node. Okay, let's see. File node. Okay, it says it's ASCII text, so it's a text file. Now, how would you create the file named new node? Okay, how would you create? Of course, to create is to use touch because it's a file. Touch new node. ls. Okay, we have new node. Next, on the deployable machine, what is the file type of unknown one? Okay, let's check the file type. File unknown one. It's an ASCII text. How would we move the file, my file, to the directory, my folder? So mv, my file, my folder, ls. Okay, so my file, went to my folder. What are the contents of this file? Okay, so that's cat. Okay, so here we are not inside my folder yet, but let's try if we can cat my folder. However, we don't know what's inside. Let's pretend we don't know what's inside the my folder. So how can we cat what's inside the my folder? Okay, so we learned it already, right? So we're going to use cd my folder ls, okay, my file. Next, let's cat my file. So we have the thm file system. Continue to apply your knowledge and practice the commands from this task. Okay, so if you want to practice, you can do it. Next, cd, go back, in order for us to go back to our main directory. Now, if you wanted to clear everything, you can type clear, and everything will clear out. Next, task 5, permissions 101. As you would have already found out by now, certain users cannot access certain files or folders. We've previously explored some commands that can be used to determine what access we have and where it leads us. In our previous tasks, we learned how to extend the use of commands through flags and switches. Take, for example, the ls command, which lists the contents of the current directory. When using -l switch, we can see 10 columns, such as in the screenshot below. However, we are only interested in the first 3 columns. Okay, so let's take a look. ls-l. Okay, so we have -rr, -r, -r, right? And there is like drwxr, something like that. Okay, rw, rwr. Okay, next. Although intimidating, these 3 columns are very important in determining certain characteristics of a file or folder and whether or not we have access to it. A file or folder can have a couple of characteristics that determine both what actions are allowed and what user or group has the ability to perform the given actions, such as the following: read, write, and execute. Okay, so let's try to look at the meaning of that. What is rw -r -r and then --? And let's have a look. So -rw -rr. Okay, so the first, see, take a look at this one. Okay, so -rw -r. Okay. So the first one, RW, it means the owner permission. So the user who owns the file can read, can write, and then here on this one says R on O, but cannot execute because only R in W. So the owner can only, or the user too, can only read and write. Next, R dash dash, the group permissions. So the group members can here read, but cannot write or execute. So this group can only read. Next, the same thing, RR, but this one means everyone else. So RW, the first one is the owner permission. The second one is the group permission. And the third one is the other permission, so everyone else's permissions. Okay, so everyone who is not the owner and not in the group can read, but cannot write or execute. So dash rw dash r dash dash r dash dash, it means a normal file where the owner can read and write, the group can read only, and the others can read only. Okay, very good. But what if we have the DRW XR? What's the meaning of that? Okay, so for the DRW, let's say, so for the D, it means it's a directory or a folder. So next, the RWXR means the owner permissions. The first three letters after D, RWX. So RWX is the owner permission. Can read the folder, list the contents. It can also write, means it create, it can delete files inside. It has the permission X. It can enter the folder. Next, the R is a group permission. Group can read list contents, but missing the write and execute. Okay, so this is very important if we wanted to know everything. So first one is the owner permission, the group permission, and the other permissions or everyone else's. Okay, and then the D is the directory or folder. Okay, so briefly, the difference between users and groups. The great thing about Linux is that permissions can be so granular that whilst a user technically owns a file, if the permissions have been set, then a group of users can also have either the same or a different set of permissions to the exact same file without affecting the file owner itself. Let's put this into a real-world context. The system user that runs a web server must have permissions to read and write files for an effective web application. However, companies such as web hosting companies will have to want to allow their customers to upload their own files for the website without being the web server system user, compromising the security of every other customer. We'll learn the commands necessary to switch between users below. Switching between users. Switching between users on a Linux install is easy work thanks to the su command. Unless you are the root user or using root permissions through sudo, then you are required to know two things to facilitate this transition of user accounts: the user we wish to switch to, the user's password. The su command takes a couple of switches that may be of relevance to you. For example, executing a command once you're logged in or specifying a specific shell to use. I encourage you to read the man page for su to find out more. However, I will cover the -l or login switch. So simply by providing the -l switch to su, we start a shell that is much more similar to the actual user logging into the system. We inherit a lot more properties of the new user, i.e. environment, variables, and the likes. su user2 password. So for example, when using su to switch to user2, our new session drops us into our previous user's home directory. su-l user2. Okay. Where now, after using the -l, our new session has dropped us into the new home directory of user automatically. So on the deployable machine, who is the owner of important? Okay. So here, who is the owner of the important? Let's see the owner right here. User2. Owner. R is the owner. R. Next, what would the command be to switch to the user2? So if we want to switch to the user2, let's use the su. the sudo command su user2. But before we do that, let's use pwd. Okay, so we are in home Tryhackme. Now sudo user2. Okay, password. Now switch to the user2 using the password user2. Okay. So again, the command to switch to the user2 is su user2. And now, if we're going to switch to this user2 using the password user2. Okay, user2. Okay, pwd. We have home/tryhackme. But here in our directory, we have in home/tryhackme user. Earlier, we are only on Tryhackme at Linux 2. So now we have in user 2 at Linux 2. So no answer needed. Now output the contents of important. What is the flag? Now let's try to output the contents. Let's try to take a look. Okay. So if we are going to ls, since we are inside user 2, if we go into ls, we can see the important flag right here, my folder, the new node, node 2, and unknown. So let's try to output or cat important. THM-SU user2. So now let's go to task 6, common directories. All right. Okay, so before we go to task 6, let's go back to our main directory. Let's clear this one. Okay. All right. CD slash, what are we earlier? That. Okay. Okay. pwd. Okay. User at Linux 2. What if we cd more? Boop. Okay. pwd. Okay, so we're starting the root ls. Okay. Clear. su user. Wow, user does not exist. Clear. Common directories at etc. Okay, let's go to Tryhackme. cd/Tryhackme. Okay, no such file or directory. cd dash ls user. Okay, cd user. Okay, ls. Pin games, blah, 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 blah. Okay, actually this has nothing. Just trying to check. Cd. So where are we earlier? User 2 at Linux 2. Are we in user 2 earlier? Well, actually, we are, let's see, Tryhackme, right? We're in Tryhackme. Let's go back to Tryhackme. And paste. Yes. Tryhackme. Clear. So task 6. Common directories, etc, var, root, tmp. etc. This root directory is one of the most important root directories on your system. The etc folder, for etc., is a common place location to store system files that are used by your operating system. For example, the sudoers file highlighted in the screenshot below contains a list of the users and groups that have permission to run sudo or a set of commands on the root user. Also highlighted below are the passwd and shadow files. These two files are special for Linux as they show how your system stores the passwords for each user in encrypted formatting called SHA-512. Okay, Tryhackme Linux 2. Let's try to take a look. ls, we still have this one, but here it says let's go to etc. So cd/etc. Okay, next ls. Okay, we have here it says all highlighted below are the passwd and shadow. Okay, shadow, passwd, sudo words t. Okay, where's shadow? Element of EQRS. Here. All right, shadow, passwd. Okay, sudoers. Sudoers.d. Okay, next. So this right here, these two files, passwd and shadow, are special for Linux because they show how your system stores the passwords for each user. However, those passwords are encrypted formatting called SHA-512. Okay, let's have a look. Let's get shadow. Cat shadow. Okay, permission denied. We don't have access to this one. Haha. Okay, next. Maybe let's use the sudo command later. What if we use the sudo command right now? su. Okay, let's go back. So cd/root. Okay, next. su user2. Password user2. Okay, now let's try to use this. cd to etc. Let's clear this one first. Next, let's use ls to the etc. Okay, and next let's get shadow. Okay, still permission denied. We are denied permission. Okay. All right, so perhaps let's go back. cd. So ssh, Tryhackme. And oh, well, why I keep on typing? Like I can use the up arrow, but seems like we cannot do it right here because we are now in another user. So ssh, Tryhackme at, let's see if we have the IP address. No, we don't have the IP address. That's clear. ssh, Tryhackme at IP address. Need you. Go. Paste. Okay. Password. Tryhackme. Clear. All right, so var, the var directory with var being short for variable data is one of the main root folders found on a Linux install. This folder stores data that is frequently accessed or written by services or applications running on the system. For example, log files from running services and applications are written here, /var/log, or other data that is necessarily associated with a specific user, databases, and the like. Okay, so dash var. So cd-var. ls, backups, cache, crash, leave local. So again, here, So var is one of the main root folders found on the Linux. This folder stores data. So this folder stores data that is frequently accessed or written by services or applications running on the system. Okay. Next is the root. Okay. Before we do that, let's see the first. Okay. Unlike the home directory, the root folder is actually the home for the root user system or the root system user. There isn't anything more to this folder more than just understanding that this is the home directory for the root or user, but it's worth mentioning as the logical presumption is that this user would have their data in a directory such as home root by default. Okay, but we can still try cd/root. Hmm. Root permission denied. Why? Is it because we are already in the root? pwd. Hmm. cd to home. ls Tryhackme Ubuntu user 2. Okay, let's go to cd Tryhackme. All right, so we can go ls Tryhackme Ubuntu user 2. No such file or directory. cd dot clear ls. So we have right here bin diff dot. Are we really right here? Why is it? Okay. Then cd we do this. No such file directory. cd dash. Okay. What if we cd and then use this one? Can I do that? No such file in the directory. Hmm? Okay, so what's the difference between this one? Import my folder. Okay. And then pwd slash home slash Tryhackme. Okay. What if we cd to root? Permission denied. TMP. This is a unique root directory found on a Linux install, short for temporary. The TMP directory is volatile and is used to store data that is only needed to be accessed once or twice. Similar to the memory on your computer, once the computer is restarted, the contents of this folder are cleared out. What's useful for us in pen testing is that any user can write to this folder by default, meaning once we have access to the machine, it serves as a good place to store things like our enumeration scripts. Some notable contents of the TMP directory. ls/tmp. Okay. cd/tmp. ls. It's not private. Okay. Okay. Dash home/Tryhackme. So here it says readme. Okay. What is the directory path that would we expect logs to be stored in? Okay, so we're talking about the log. So okay, we do use the cd slash var slash log. Yeah, and those var log. What root directory is similar? Or let's just cd slash var slash log. Okay, var logs, ls logs. We have all the logs right here. Author log, auth log, authentication log to we have the different logs right here. Okay. Next, what root directory is similar to how RAM on computer works? Okay, cd slash tmp ls. Okay, here. So TMP directory is a volatile and is used to store data that is only needed to be accessed once or twice, similar to the memory on your computer. Once the computer is restarted, the contents of these folders are cleared out. Name the home directory of the root user, that is slash root. Next, now apply your learning and navigate through the directories on this deployed Linux machine. Okay. Now, nice work. This room was quite theory heavy and covered quite a range of fundamentals in getting you familiar with Linux. To quickly recap, this room taught you how to connect to a Linux machine remotely using SSH, advancing your use of commands by providing flag switches and where you can go to learn about this for each command. Some more commands that you'll frequently be using to interact with the file system and its contents. Brief introduction to file permissions and switching users. Summary paragraph of the important root directories on an Ubuntu Linux install and how we may be able to use the data stored within this. Okay, correct answer. And task 8 is the next fundamentals in Linux, which is the part 3. So terminate the machine from task 2, terminate, and then join Linux fundamentals part 3. So I'll see you in part 3.